Now let's discuss the continuity of a function. Now just to be clear, what continuity is basically, say you have this function over here. At this point, right, let's just say this is f of x, and this top point over here, this maximum is at L, and the x coordinate is at C, right? Now you can see that when you approach this function from the left hand side and the right hand side, you can see it approaches the same point, L, and that means that this function is continuous, right? Because there is no break. But although if you now look at this function over here, right, at this particular x point, let's say this is C as well, and let's say this here is M and this is N, right? You can see that there is a discontinuity at C, because from the left hand side it approaches N, but from the right hand side it approaches M, and this is the discontinuity at C. So this is just a brief explanation of what a discontinuity is. Now the question states that we have discussed the continuity, so we have to tell if the function is continuous or discontinuous at x is equal to C. So in this particular example, C is equal to 2, so we have to find the continuity at x is equal to 2. Now the function itself, when x is less than or equal to 2, the function is 2x plus 5, but at x values greater than 2, the function is equal to 4x plus 1. So let's see what the solution is. First you have to find f at 2, right? Now because the question states that we have to find the continuity at 2, so first you have to find the value of the function at 2. Now you can see when x is less than or equal to 2, it is equal to 2x plus 5. So you'll use this equation, this expression, 2x plus 5. So you input, in place of this x, you input 2. So instead of 2x plus 5, you have 2 into 2 plus 5. And so you get 9. Okay, so that's your value of the function at x is equal to 2. Now you have to find the left hand limit. So the left hand limit means when x approaches 2 from the left hand side, what do you do? Well, you can see when the value of x is less than 2, you have again this expression, 2x plus 5. So this means that the function is equal to 2x plus 5 when x approaches 2 from the left hand side, because it's less than 2. So you apply the limit, the left hand limit, into 2x plus 5. So again it is equal to 9. Now you have to find the right hand limit, because again I showed you the example. You have to find the right hand limit and the left hand limit to basically find a conclusion on the continuity. If the left hand limit and the right hand limit, if the left hand limit is equal to the right hand limit, that means that it is continuous. So let's see the right hand limit. So you're approaching 2, x approaches 2 from the right hand side. Now the function was equal to basically 4x plus 1 when x was greater than 2, right? And it was equal to 2x plus 5 when x was less than or equal to 2. Now approaching from the right hand side, you'd use this expression, 4x plus 1, because it is the function value for when x is greater than 2. So you input the limit x approaches 2 in 4x plus 1, and that equals 9. So you can see that the left hand limit is equal to 9 and the right hand limit is also equal to 9. So just a second. So you can see that the limit as x approaches 2 exists because the left hand limit and the right hand limit are equal. So the limit of f of x as x approaches 2 is equal to 9, and so the function is continuous.